Javane Macchiato loves coffee. She can purchase C-cups of coffee from the fast food giant McDowell's or L lattes from the upscale Cafe Marquis. McDowell's charges $2.10 per cup of coffee, while a Cafe Marquis latte costs $7.14. Her annual budget for coffee is $715. Her budget constraint is given below. B is the amount she budgets per year. This here is the amount she spends on coffee each year, which is the number of coffees times the price of coffee. And this here is the amount she spends on lattes each year, which equals the number of lattes times the price of lattes. Solving the above equation for the number of cups of coffee purchased from McDowell's gives this equation. We've subtracted this from both sides of the equation, and we divided through by the price of coffee. So we have the intercept of her budget line being the budget divided by the price of coffee, minus the slope of the budget line, which is the price ratio, price of latte divided by price of coffee, times the number of lattes she decides to buy. Substituting her annual coffee budget, which is 715, into this equation right here, 715, and the prices of coffee and the lattes gives her budget line in the graph below. So the intercept is the budget, 715, divided by the price of coffee, which is $2.10. Rounding to two decimal places means I have to change the 7 to an 8. Then I'll calculate the price ratio. The lattes cost $7.14 and the coffees cost $2.10. And that ratio is 3.4. I'm going to press enter to see if I got it right. And I did. So this value here, the height above the origin here, is 340.48. It is the number of coffees she would purchase if she purchased 0 lattes at a price of $2.10. And the line is downward sloping because the slope is a negative 3.4. Her budget line is the downward sloping line in the graph. Notice that the curve bowed inward, this one here, toward the origin is tangent to the budget line, meaning the budget line and the indifference curve touch at exactly one point, and that one point is this black dot labeled O. This curve is her indifference curve, and the point it just touches, her budget line, is the optimal consumption bundle of McDowell's coffee and Cafe Marquis lattes. At the optimal consumption bundle, point O, she chooses to purchase how many lattes? Well, at this point here, she chooses 51 lattes. And at this point, she also chooses 167 cups of McDowell's coffee each year. Now, anywhere on this budget line, she is spending all of her budget, and her budget is $715. So if you were to multiply this by the price of coffee, and then multiply this by the price of lattes, and you add the two together, you'd get 715 after you round to 0 decimal places. Now, this bundle of 167 and 51 yields her utility of 49. Now, the marginal rate of substitution is the slope of the indifference curve. Notice the MRS is pretty large here, but it's pretty small here. I'd rather walk this part of the line from this point up to that point than have to walk from here up to there. This is a very steep climb. This is not a very steep climb. So the marginal rate of substitution along this curve changes as we buy more and more lattes and fewer coffees. Now the slope of the budget line is constant, equal to the ratio of the prices. And the ratio of the prices was 3.4. We took the price of latte divided by the price of coffees, and we got 3.4. The budget line has a constant slope, and its slope is called the economic rate of substitution. The slope of the indifference curve is called the marginal rate of substitution, and it changes. But at this optimal point where the indifference curve just kisses the budget line, the slope of the indifference curve equals the slope of the budget line. So this right here is equal to the slope of the budget line, a negative 3.4. And that only happens at the optimal solution. I'm going to press enter to make sure I got these answers correct before I move on. Now, this negative 3.4 means what? I'm going to come over here to Desmos. I'm going to type a negative 3.4 divided by a plus 1. And I get negative 3.4. So what this means here is this curve at this point, if I decrease coffee consumption by 3.4, if I go down 3.4, if I want to keep my utility constant, I have to go over 1 to keep my utility constant at 49. That's what that means. So I go down 3.4 over 1, and that keeps me on the indifference curve of utility equal 49. What this number implies, she is willing to give up 3.4 cups of McDowell's coffees to get an additional Cafe Marquis latte, holding her utility constant at 49. Now, moving along the indifference curve, I've already mentioned this, it is really steep here. And as we come down the indifference curve, the utility remains constant at 49, but the slope is getting closer and closer and closer to 0. If we were to extend this out, it'd get really close to 0, the slope. Utility remains constant as the MRS gets closer to 0. This should be 714. So the intercept is 340, which we have there. Now, if McDowell's raises its coffee price 40%, let's do this. I'm going to insert a row above here where we have the original price times 1 plus a 40% increase in the price. So the new price is 2.94. We need to calculate a new intercept. The new intercept is a 714 divided by the new price of 2.94. And then we need a new slope, which is going to be the original latte price divided by the new coffee price, 2.94. When McDowell's raises its coffee price 40%, the coffee price is going to go from 2.1 to 2.94. And that's going to cause the intercept of the budget line to go from 340 down to 242, well, 243 if we round to 0 decimal places. The intercept will come down to about 243. And then the slope will go from 3.4, so it's pretty steep at 3.4. At the new coffee price, the slope will be 243. So this black line will get flatter. So let's go ahead and choose flattens right here for the budget line. And you can see that the budget line is flatter. The intercept did fall from 340 down to 242.86. Notice that the budget line did not rotate at this point. And that's because the x-intercept at this point is the budget divided by the price of lattes, and the price of lattes never changed. It was always 7.14. So this value here is 100, before and after the change in the price of coffee. So we have a point of rotation right here, and the line gets flatter. Notice we have this new consumer budget line. It has an intercept equal to 242.86 and a slope equal to 2.43. That value rounded 2 decimal places. At the new optimal solution point F, she consumes 55 lattes and 109 coffees. And that's because the price of coffee went up. When the price of coffee goes way up, her consumption of coffees goes way down. The interesting thing is she ends up buying more lattes. And I think that's because if the coffee price is higher, it's much closer to the latte price, then it makes the lattes more affordable, so she purchases more lattes. Though the bundle still cost her, remember the bundle is still costing her $714 because this original budget line, anywhere on it was $714. That budget line intersects this red budget line at this one point. Every consumption bundle on the red line cost her $714, and every bundle on the black line costs her $714. So that hasn't changed at all. So she's still spending $714. It yields her less utility though. When you go from point O to point F, utility falls from 49 to 44. Her marginal rate of substitution at point F is equal to the slope of the budget line. Now, remember the marginal rate of substitution changes as we go up the indifference curve. But at this one point, the slope of the indifference curve, the marginal rate of substitution, is equal to the slope of the new budget line, which is negative 2.43. At point F, the marginal rate of substitution equals that value, negative 2.43. And that implies she will give up 2.43 cups of coffee at this new higher price to get an additional Cafe Marquis latte, holding her utility constant at 44. Now, McDowell's pricing decision raises the price Javine Macchiato pays for a cup of coffee from the fast food giant by how much? Well, the new price is 2.94 and the old price was 2.1, and that is a difference of $0.84. And that resulted in what? Her purchasing fewer coffees. She purchases 167 minus 109 fewer copies, which equals 58. So this is 58. I'm going to press enter to make sure I got those right. The slope of her coffee demand curve, where we have price on the vertical axis and quantity on the horizontal axis, the slope of that would be the ratio of these two changes. So 0.84 divided by 58, which when you round to two decimal places is negative 0.1. So it'd be a negative 0.1. The increase in the price of McDowell's coffee has multiple effects. First, it results in Javine's utility decreasing, as we mentioned, right? Her utility decreased from 49 to 44. Now, when I press enter here, or I click submit, what will happen is the income effect and the substitution effect will be decomposed by point H. I call it point H because we call this budget line the hypothetical budget line. We can also call this point H because the economist Hicks came up with this. So the income effect is from point O to point H. And then the substitution effect is we hold utility constant at this new lower level of 44, and we slide along the indifference curve to point F. So this captures the holding utility constant while the price changes. And that happens from point H to point F. So that's the substitution effect. The income effect is from point O to H because if you look at the black budget line and the green budget line, they're parallel. And when you have parallel budget lines, you're assuming that the prices haven't changed. The income effect is represented by the movement from points O to H, as I mentioned above, from here to here. As the price of McDowell's coffee rises, Javine feels poor because her original coffee latte bundle is no longer affordable, even though her actual budget hasn't changed. So her purchasing power shrinks and she is pushed to a lower indifference curve. The amount of money she would need to purchase her original bundle of caffeinated beverages at the new coffee price is what? At her original coffee bundle, she's purchasing 167 coffees and 51 lattes. The original latte price is 7.14. It did not change. But the coffee price did change. It changed to 2.94. Therefore, in order to purchase bundle O, the original optimal solution, she would need $855, which is rounded to 0 decimal places. With $855 being the amount she needs now after the price change, we subtract from it what she needed before, $714. Thus, she feels $141 poorer. So the price change feels like her income fell $141 because that's the amount of money she would need to go back from H to O. That's why this is called the income effect. Now, if this problem were not about the price change and it was just about changing her income by $141, the red dot would not exist. The red budget line would not exist. The green dot would be labeled final, instead of hypothetical. And we'd have a shift from O to H, and a decrease in income of $141 would only have an income effect. But that's not the case here. This price change makes her feel like she has 141 fewer dollars. So that pushes her from O to H. So the number of lattes she purchases falls in the income effect from 51 to 42. For the income effect, the number of coffees decreases from 167 to 147. Now, the substitution effect is modeled by the slide along the indifference curve, the red one, where the utility is 44. So we're going to hold the utility constant at 44. And this is where we pick up the relative price change. Because if you look at point H's budget line, it's steep. Point F's budget line is flatter. That change in slope is reflected by the change in the price of coffee. So we're sliding from H to F and we're holding utility constant. When we do that, coffee consumption falls from 147 to 109. And latte consumption increases from 42 to 55. And if you look at the income effect for lattes, the decrease in lattes from 51 to 42 is smaller than the increase in lattes from point H to point O. So we say the substitution effect dominates the income effect for lattes. The substitution effect dominates in coffee too. The decrease in coffee went from 167 to 147 on the income effect, but it went from 147 to 109 on the substitution effect.